Um, so Professor, this is lab one. We're doing analysis of simple DC circuits. These are group members.
My name is Elliot Machat, and Panther ID 6330100.
My name is Sebastian, Panther ID 6315456.
And my name is Fabio Macias, Panther ID 6243957. Group 9, and then our course is EL 3110C.
The objective of this experiment is to understand and demonstrate how to properly design, measure, and simulate simple resistive circuits using multisystem. In this case, we're using multisystem online.
In activity 4, I created the circuit according to the schematics. Also in activity 4, it was basically the same as activity 3. In scenario A, the first resistor was larger than, in scenario A, the resistor was smaller. And in scenario B, the first resistor was smaller and the second one was larger. Scenario B, the first one was bigger and the second one was smaller. And scenario C, they're both equal. In this one, we had to measure the total resistance, the total voltage between A and B, A and C and B. And we also had to measure the currents in different areas of the circuit. We also had to calculate a formula specified. It was basically the total voltage VAB over the first current. Go to the first, yeah. And scenario A, it was for the total voltage was 5 volts. The formula was basically the same as the total resistance. It was 5 over 1 milliamp. So it both of those are 5K ohms. For the voltage in between A and C is 5 volts, and the voltage between C and B is 2 volts. The current in each one of the places in the top and between the two resistors and in the bottom, the three of them had the value was 1 milliamp. Go to B. In scenario B, it was basically everything was the same, except that since the resistor values change, the total voltage between A and C was, between C and B was 3 volts. So that's the only thing that changed from activity A. And now go to scenario C. And scenario C, everything is basically the same. The current is the same, 1 milliamp hours. The total voltage is 5 volts. The formula is also 5K ohms. The only thing that changes is the voltage from C to B is at 2.5 volts. And go to the analysis. So basically the analysis of activity 4 is that by changing the resistor values on each resistor, only change the voltage in nodes A and C. The node B didn't really change. The current was also not affected in any way. So for each scenario and each specific node that detected the current stayed the same at 1 milliamp, and the total voltage and total resistance also stayed the same no matter how many times we change the values of the resistors. So the discussion and conclusion, the simulations done for this lab through multisystem demonstrate and prove that mathematical concepts that we have learned so far in the class, working with resistors in parallel and in series can lead to different are equivalent due to their setups. Or overall, the objective of this lab was obtained, and we learned more about the different elements of simple resistive circuits. So in other words, we learned a lot about how to use resistors, how to measure the current and the voltage in each part of them. And yeah.